So I'll in this presentation I'll be explaining how I did my compost for my soil chemistry final project, and it is called the art of cold lazy composting. It's called lazy. We're going to see why it's lazy in a way. And there are many other methods like hot composting, which is the opposite of cold composting, and I'll explain why. There is vermicomposting, which uses decomposers such as worms, but I decided to settle on cold composting, and it can be called a sort of lazy way to do composting, but it is pretty effective. So we're going to see why in a bit. So first of all, this is an overview or of what will be, I'll be explaining the general background of what compost is and what the method I choose is and why did I choose it. And then I'll be showing the different materials that I gathered to do my compost. And as well, I'll be explaining what is occurring, what is the chemistry behind composting, why is it done, what is happening in that degradation of the raw materials to getting the compost. And then I'll be explaining some misconceptions, some pros and cons, and also some challenges I went throughout carrying out this final project for my soil chemistry course. So a little bit of background. What is compost? So compost is per se the breakdown and the composition of organic material into humus. And humus is something that contains nutrients that are essential for plant growth. So knowing what is compost, we can go onto what is cold composting or lazy composting in quotes. This is called lazy composting because unlike hot composting, where it only takes about, you need high temperatures and it only takes around a month or two. Cold composting is a lot slower. As mentioned, it does not occur in that high temperatures, so it occurs a lot slower. And it is just the addition of the different brown and green materials sort of piling it up. Like how I did it, I had my container and I just added the brown and the green materials. But what I did is I kept in mind a certain ratio because when it comes to hot composting, there is a 10-to-1 ratio from carbon to nitrogen material because your carbon is your brown material and your green is in nitrogen material. But here in cold composting, like I said, is just piling up of these materials. So what I did is that I did it in layers, a layer of brown, a thin layer of green, and then so on sequentially until I used up all my material into this container that I did. So that's why it's called lazy composting because you just pile it up and leave it there, unlike hot composting, where you just add them in this correct ratio and then you turn it over every once in a while so that it creates heat at a certain temperature. That is hot composting, but this is cold composting. This is lazy because you're just throwing in whatever you have and just leaving it there, forgetting it. That is why it's called lazy. But I wouldn't call it lazy. I would say it's more patient, if that makes sense. So it is a lot slower. The decomposition is a lot slower, unlike hot composting. And this is if you have the time. I chose this method because it seemed a lot easier per se and more feasible to certain environmental factors that I experienced that I will be discussing later. Because with hot composting, you will need to keep an eye on it constantly. You will need to turn it every now and then. Well, not that much, but that's what I mean. So with cold composting, I just added my materials and then just left it somewhere so that per se nature by itself decomposes it in a way. And when I just come around to look at it, it's decomposing. So that's why it's called cold composting or lazy composting. So as I mentioned, using my cold method, the organic materials that I'll be showing in a while that I did, well, I added, I just added and piled up on top of each other so they start decomposing. And what are these type of materials I already mentioned? They are green and brown. As I mentioned, the green would be sort of fresh in a way. That's why they would be high in nitrogen and moisture content. So this would be like coffee grounds, fruit and vegetable scraps, which is one of the main ones I used, grass clippings from mowing the lawn, manure. I didn't use manure, but manure can be used, and some finished plants or plants that per se are trimmed from others. So this would be the green ones. The green ones are high in nitrogen. This is your nitrogen source. And then the brown one would be high in carbon because there needs to be a high carbon content as well as nitrogen. So we need carbon and nitrogen. So those are the brown materials. These have less moisture because it's mostly dried out stuff that we added. Such things such as cardboard, wood, dead plants, dead leaves, branches. I'm going to show what I used. And as I mentioned, I did it in a 2-to-1 ratio, unlike hot composting, which is usually 10-to-1. This because I did it in layers, because in cold composting, you can just add it and pile it up, pile it up. And hot composting, you cannot do this. You have to be careful with the ratios. So I made sure to add diversity to mine as well, because when it comes to cold composting, yes, you can add your organic material however you want, but you need to add diversity and variety of different materials. So that is what I did to ensure my compost has a diverse range of materials. There are common misconceptions when it comes to creating compost that, I don't know, people tend to have per se in a way. So there are many things that can go wrong in the process, whether it's being carried out or where you're putting it. For example, people think that when doing compost, it might give off unpleasant stench, and this can't be further from the truth because if you control your ratios, as I mentioned, this will not happen. An example is that if you add too much green material, like your fruits and vegetables, obviously those will rot with time. So if you add too much of that, that would just be a pile of rotten food scraps, and that would obviously give a stench to the release of ethylene gas. So you can control that by adding the correct amount of ratio from carbon to nitrogen. So this is a common misconception. The next one is that people think compost attracts pests. And it doesn't necessarily, if you do not add per se food scraps, that is what mostly attracts these little creatures here, rodents. And again, this can be fixed by adding the correct amount of carbon to nitrogen ratio. And the next one is that you shouldn't add any dairy foods because dairy foods wouldn't be as ideal to add to your compost, and microorganisms wouldn't thrive in this environment. And also people think you need a lot of space for compost. This is not true. You just need like a small bin where you can put your stuff and constantly supervise it. So that's another thing. So as I gather my materials, as I mentioned, my brown ones would be dead leaves, dead branches, sugarcane leaves, the brown ones, and some dark soil. As I can see here, my materials for the brown ones. My green ones were mainly fruit and vegetable scraps. I controlled it so that the stench wasn't that bad. Some grass clippings and some finished plants. So those are my ratios, and I added in thin layers. So we can see here the first week, we don't see that much decomposition, but as we go across the second week, we can see some decomposition occurring. And as we go to the third and fourth weeks, we can see some of the leaves still sticking out, some of the some of the dead plants, some of the fruits still there, because as I mentioned, cold composting can take a while. And then finally, weeks 5 and 6, you can see finally some more decomposition and degradation. And this is what the end product that I obtained recently. So this is what happened. Now I'm going to explain the chemistry behind composting. So during composting, there is heat being released, especially when doing hot composting, because this is due to the activity of microorganisms breaking down the carbon from the brown material and the nitrogen from the green material in compost. And in aerobic decomposition or composting, it is usually the carbon material being oxidized to produce carbon dioxide and then release water or moisture in or retain it as well. So as you can see here in this image, the microorganisms plus the nitrogen plus the carbon react with oxygen, and the carbon will get oxidized to give off carbon dioxide, heat, and water. And it is divided into 3 phases: the mesophilic, the thermophilic, and the mature stage. The mesophilic is mainly due to mesophilic bacteria because it helps the compost rise in temperature, so the microorganisms give off heat. And then the temperature increases because of the thermophilic stage. Again, thermophilic means loves temperature, so the thermophilic bacteria make it increase in temperature, and maturing is that the microorganisms use up the available carbon and nitrogen to release heat and carbon dioxide, so it is said to be mature and ready. And another things to keep in mind is that these reactions, you need to have a range in pH that is not too acidic or not too basic. In this range, 6.5 to 8. And you also need the presence of moisture and oxygen because it needs to be oxidized. So how is this important for soil fertility? Humus from compost is important because it contains the nutrients that it is able to dissolve in soil, right? So some soils like clay soils, which is present in my area, are deficient of certain minerals. So the soil colloids would contain these necessary cations: calcium, magnesium, potassium, sodium, and this will be essential for plant growth. So since they are in the humus, they get dissolved into the soil and it is more available for the plant to absorb them. So the addition of humus improves the fertility of soil, right? And the fertility of soil depends on the capability of the soil to hold and exchange cations. This is the cation exchange capacity, CEC. So without the soil colloids from the humus, most of the nutrients would just be leached out from the soil, and this would be just waste through water runoff. So, and this is just some notes about how the soil, the bases in the soil determine its basicity. And if soil colloids have small amount of bases, it would hold less of these cations and make it less fertile. And how soils become acidic, the acidic ions just replace these nutrients in the soil colloids, and the acid ions would just kick out and accumulate. And that's why a soil becomes acidic, which is infertile. And just some final thoughts and challenges. So we all know that an advantage of compost is that it improves soil quality. It reuses organic waste like kitchen scraps and whatnot. It can be used as fertilizer for plants. It is eco-friendly. It is not that hard to produce, and you get that sensation that you're helping the environment to do something well as improving the structure of your soil, right? As you can see here, I use my compost for farming and growing crops, so that is a good thing. But there are a lot of things that can go wrong. As you can see here, you can attract pests, you can attract, well, you can give off an awful stench from it if not done properly. It involves a lot of elbow grease. You need to do a lot of work with it. You need to gather, you need to turn it, you need to do a lot of things. And it depends on the ingredients you add as well. You cannot add too much from each carbon or nitrogen source. And as I mentioned, my cold method takes usually longer than the hot composting. And also compost needs protection from rain and other external factors. Some challenges I faced, some heavy rains from the flooding recently. ruined my first batch of the compost, so I had to restart it. And then Hurricane Lisa, recently this year, again, might have affected. I think some moisture got into my compost, but I think it turned out well, as you can see here in my image. Yeah, I think that looks good enough for compost at the end of week 6. So I also had to find a good place for it to not make pests get into it, to keep it away from my pets and people, and not knowing what to do at first was kind of a challenge. So I also had to transfer it from a container to another. So, and these are my references: The Art of Laser Composting and How to Do So. Thank you.